Hey everybody, we are now in the last video of our course, a mini project again. Our second mini project is a weather station. Now, without further ado, let's get straight to it. I trust that everybody will already know what is going on in this particular mini project. You guys will already be knowing everything by now. Considering all the tutorials that you must have watched to come to this part of the course, the final last project. This is, as I told earlier, it's going to be way, way simpler than our home automation. There's only three sensors here. This particular potentiometer is standing in for the wind speed. We don't have any particular component here to, act as that. We have an LCD to display everything. We also have a soil moisture sensor here standing in as our humidity sensor. We also have our good old LM35 temperature sensor. And this particular potentiometer here is used to adjust the brightness of our LCD screen. You would have already learned how to interface Arduino Uno with an LCD display to display things. So we are not going to be logging anything on the serial monitor here. Everything is going to be displayed on the LCD. Now, I'm not going to be explaining any of the connections either. You must already be having a basic idea. Every sensor has a ground pin, a power pin, and one, data pin. Data or signal, there's power, there's ground, and there's signal. Again, there's power V out, which is output, and ground. And over here it's terminal 1 wiper, terminal 2, which is being used as a sensor here. Then it's the same. I was wrong, it's not an LM35, it's TMP36. I mean, every particular component you select, you can get additional information regarding it over here. Now let's get into the code. We are using an LCD, so we're automatically including our liquid crystal library. And we have connected data pins 5, 4, 3, and 2 digital pins to our LCD over here. And now our LM35 is connected to analog 0, the humidity sensor is connected to analog 1, the wind sensor is connected to analog 2. And we are initializing our LCD now, void setup, void loop. Now let's get into void setup. Our LCD, we are, segregating it into 16 columns and 2 rows. And we are just going to print weather station at the beginning. We're just turning the system on. It's going to print weather station for 2 seconds and then it's going to clear it. Now void loop, what's the system going to do? LM35 raw, like I mentioned before, we cannot just directly use our sensor data. We're going to process it and we're going to calculate our temperature so that we can actually, use it into degrees Celsius. And now humidity sensor, similarly the moisture sensor is not going to directly just give us the moisture. We're going to be converting it into a value between 0 and 100 because humidity is actually measured in percentage. And now let's go ahead with wind draw speed. The wind speed is also being mapped between 0 and 100 here because the potentiometer is going to give us a maximum of 1023. But wind speed is not measured in percentage, it's measured in kilometer per hour. And right now, for the sake of simplicity, we're just, mapping it into a particular value that we can display it. We're setting up and we're developing this particular application. Everything is up to your convenience. And now we're going on to our displaying module. LCD set cursor 0, 0. So our first row, first particular cell, we're going to print the temperature. comma LCD dot print temperature, this particular float, comma 1, we're rounding it off to 1 decimal point. And now set cursor 0, comma 1, the first cell in our second row. We're going to print H for humidity, rounded off to 0, which is going to be like non-decimal number in percentage, and W for wind speed, again rounded off to 0 into a non-decimal number in kilometer per hour with a delay of 1 second. 1,000 microseconds make 1 second. Now let's try and start simulation. Again, as the weather station has started, 2 seconds later it's going back. Now serial monitor, there's nothing going to be printed in your serial monitor because we never really printed anything. Everything is going to be displayed on our LCD. So let's go ahead and close this. And now let's start with our temperature. It's currently 74. Now if we increase it, it's going to be increase, and if we decrease it, it's going to be decreased. Now if you're really worrying about the fact that it says minus 34 or like 17 degrees Celsius here but 66 here, then you can just this particular code is like wrong, then you need to change it. But you get the idea, right? We just processed the information wrong. There's nothing wrong in how our connections are. So the data is being sent from the sensor to our Arduino, the microcontroller, and this microcontroller is printing that on our LCD. So our goal is working. Let's go into the soil moisture, which is standing in for humidity. Humidity is currently at 0%. Now we're increasing it slowly. 34, 51. I wouldn't worry about the fact that it's at the middle here and it's 40% here. Again, that goes with changing this thing. This is all here just for show. It is just a simulation. I mean, we're not really going into the accuracy thing. I mean, if you want to, like, if it's a very, important thing, you can, always go ahead and edit this particular pre-processing step to make, work towards accuracy. And now we're going to control the wind speed, who is standing in as our wind speed, a potentiometer. As I increase this person, it's 21 kilometer per hour. And I decrease this thing, it's going to be 9 kilometer per hour. Just increase it completely. See, it's at 47 kilometer per hour now. So our potentiometer stand-in also works. And so we have successfully integrated 3 different sensors and we have displayed them on our LCD. This is a very, very basic working of a weather station. And that's it. You just built 2 mini projects, with regard to IoT from scratch using Tinkercad. Remember, what you learned here is only the beginning. The real magic happens when you start combining these skills to solve real world problems. So keep experimenting, keep building, and I'll see you in your next big IoT adventure. If you guys have any doubts, please feel free to ask in the comments. And thank you.